Okay, hello algebra fans. Today we're going to work on absolute value inequalities. Okay, absolute value inequalities. And this is a key word. There we go. This is a key word, inequalities. We've already worked on equalities where we set the we isolate the absolute value and then we set it equal to the positive and negative of the right side. Well, one of the things that we're going to do is we're still going to isolate that absolute value. That is actually really key. So we got two kinds of absolute value inequalities because we have two types of inequalities. We have greater than and we have less than. So the first thing we're going to talk about is greater than. So it's greater, and I'm going to put this in big letters, greater than. Okay, because that's actually a really key word. So this is how the problem starts. We're going to start with a real basic problem. Absolute value of x is greater than or equal to 5. So if you think about it, what values actually work in here? Anything like 5, 6, 7, 8, anything that you put in there, right? It's obviously these are greater than 5. And if I say, what about if I put negatives in here? If I put a negative 5 in there, negative 5 absolute value becomes positive 5. So that's greater. So I can say negative 5, negative 6, right? Because 6 is great. Take the absolute value, negative 6 becomes 6, etc. Negative 7, negative 8, and then it keeps going. So the only ones it doesn't work on, it doesn't work with anything that's less than 5 or greater than negative 5. Because if you put like a negative 4 in there, absolute value negative 4 is 4, not greater than 5. Okay, so that's just to kind of give you an idea of what it's going to look like. So if I would graph this on a number line, which we're going to do that, showing you now what it looks like, it's everything above 5 and less, so 5 and greater than, and everything less than or equal to negative 5. That's the idea behind this problem. And the reason, again, I highlighted this word or is because that's what most of our or problems looked like. It was either all real numbers or it was like a scarecrow like this, less than, pointing one direction and pointing the other direction. Okay, so let's go and let's talk about, let me rewrite this problem here. Absolute value of x is greater than or equal to 5. This is the setup for this. This is the setup for every single greater than problem or greater than equal to problem. They're the same. Okay, every single setup. So what you're going to do is you're going to say x is, and I'm going to put this in red because it's always the case, x is less than or equal to negative of that 5. So that value comes down here. And or, so again, anything in red is always going to be the case. Or x is going to be and this is going to be greater than or equal to positive of that number. Of 5. So you notice that 5 was here in both places, 5 and 5, but one is less than or equal to negative of that value or greater than positive of that value. So the values or the writing that I just put in red will always be there. If you do not have that in there for a greater than problem, it's wrong. Okay, so you have to remember that. Less than or equal to negative of that value or greater than or equal to positive of that value. And then we're actually really done, and this is just a quick problem just to show you how to set it up. And then if I'd graph it, because there are two parts to it, you have to come up with a solution, and then, well, actually it's just, I'm just redoing the same problem. So greater than or equal to positive 5, less than or equal to negative 5. Okay, so let's try a little more complicated one, but that's what a greater than problem is. Always set up that way. All right, so let's do a problem x minus 3, absolute value of that is greater than 8. So what you're going to do is x minus 3 is less than negative 8. Okay, remember, it's this part right here. That's always there. Okay, it's less than or equal to that. Or x minus 3 is greater than positive 8. And then you solve them just like the old days. Add 3 to both sides. So x is less than negative 5. Add 3 here. X is greater than positive 5. So that's my answer mathematically, and then graphing it actually turns out to be the same as the last problem. But it's open dot and open dot. And that's the answer to that problem. Pretty straightforward. Okay, so let's try another one right over here. If I have 2 times absolute value of x plus 1 minus 3 is greater than or equal to 9. So it's the same rules as equality problems. You have to isolate the absolute value. Okay, you do not distribute. So this x plus 1 has to be in this, almost in the final answer before you start solving. So I have to isolate that. You will never ever touch that until I have isolated. So this problem is just like a problem like 2x minus 3 equals 9. Okay, the first thing you do is you add 3 to both sides. So same thing here. I'm going to add 3 to both sides. So 2 times the absolute value of x plus 1 is greater than or equal to 12. So same thing here, 2x equals 12, and then you divide both sides by 2. And that's what I'm going to do here. Divide both sides by 2. Absolute value of x plus 1 is greater than or equal to 6. Now I set up 2 problems. I have x plus 1 is less than or equal to negative of that right side, or x plus 1 is greater than or equal to positive of that right side. So again, a couple key things that I have here. One is I have less than or equal to negative of that, and greater than or equal to positive of that. Okay, but I never touch that absolute value, and then at the end, so here it is. Here's the absolute value. I never touch that, and then I rewrite that x plus 1 for both of those problems. Okay, and then basically what you're going to do is you're going to solve each one of these. Subtract 1 from both sides, and I get x is less than or equal to negative 7. Subtract 1, x is greater than or equal to 5. So that's your answer. Do not forget the word or in there. That's actually a big part of it. And then when you graph it, it's always going to be a scarecrow for these problems. So negative 7, 0, and 5. So it looks like that and like that. And that's the solution to that problem. Okay, so let's try a little more complicated problem. 2 minus 3 absolute value of x minus 7 is less than or equal to negative 7. Okay, so again, this problem is just like 2 minus 3x is equal to negative 7. You're going to do everything like normal. Subtract 2, which we are going to subtract 2 here from both sides. Again, please do not distribute that negative with that the negative 3 with that absolute value of x minus 7. It's very bad to do. Okay, and then we get negative 3 absolute value of x minus 7 is less than or equal to negative 9. Divide both sides by negative 3. Absolute value of x minus 7 is greater than or equal to, don't forget when you divide by negative, you have to flip the inequality sign, greater than or equal to positive 3. It's a greater or problem. Okay, again, this is a greater than problem, so it's a greater problem. That's why it's an or problem. So it's x minus 7 is less than or equal to negative 3, or x minus 7 is greater than or equal to positive 3. So we add 7 to both sides, and we get x is less than or equal to 4. We get 7 to this side, and we get x is greater than or equal to 10. So that is your answer. Again, do not forget the word or. And then if I would graph this, I get a 4 here, and 7 here, and 10. So it's less than or equal to 4, greater than or equal to 10. And that's a solution to that problem. Okay? Pretty straightforward. Everything's the same as before with inequalities. When you divide by negative, you flip the inequality sign around, but the only thing that we learned here now is how to set up an OR, a gray TOR problem. Alright, so let's do the other kind of problem. If I said x is less than 3. Okay, this is a between problem. If it's between, it's a less than. That is very important. So this is, remember, this is a less than symbol. Okay, so betweens were less than and ORs were greater than. Okay, it's very important. ORs are greater, and between is less than. All right. So let's set or show how to solve this or set up this problem. Again, just like the OR problem, I'm going to show you exactly how to do it. If you do it any different way than this, you're going to get it wrong. Okay, so watch what I'm doing. This is the setup. You are going to take this x value, or whatever's inside of that absolute value, that goes in the middle. So I'm just going to put an x there. Okay, what I'm putting in red now is always going to be the case. Because it's less than, and I call it a between problem, it's between two values. Remember when I taught you betweens always point to the left. Very important. Okay? Then I'm going to take this 3 here, and this is the negative of that 3. So that 3, and then the positive on the other side, and you don't need to write positive, I'm just showing you that's what it is, of this 3. Okay, so x is between -3 and +3. So let's actually get rid of that +3 just to make it look more normal here. -3 and +3. And that actually is a solution to that problem. You really don't have to do any more work. Obviously, we're going to have more difficult problems, but I just want to show you the basics. And then if you graph this, just remember how it's graphed. A between problem is always a barbell. Always. So here it is, -3, 0, 3. These are both open dots because it's between these two, and that's your answer. So that's the answer you're going to put on the answer blank, and this is the graph you're going to put in the blank for the graph. That's a basic problem. Okay. So let's try a couple others now. If I said 2 times the absolute value of x minus 4 is less than or equal to 6. Okay, so it's a less than problem, but you don't even think about that until you've isolated the absolute value. Because remember that last problem with we had to switch around the inequality sign. Whatever happens after you isolate it, that determines whether it's a between or it's an OR problem. So the first thing we're going to do is we're going to divide by 2. So absolute value of x minus 4 is less than or equal to 3. So once again, this x minus 4, that goes in the middle of my between. This 3 goes over here, but it's -3. It's less than or equal to, less than or equal to. And then the 3 goes over here. And that's the setup for that. So it's positive and negative of the 3. The negative, and think of a number line. How a number line has, when you graph something, you get the lower numbers here and the larger numbers on the right hand side. Same thing with the inequality, just to help you remember which way it goes. So the negative goes on the left, the positive goes on the right, and then we solve. We add 4 to all 3 sides. Remember when we did between problems, that's how we solved it. And we got 1 less than or equal to x less than or equal to 7. Okay, there we go. So 1, 4, 7, and it's between these with solid dots. And that's the answer to that problem. So that, again, that's your answer on your blank, and this is your number line. Pretty straightforward. All right, so let's do a little more challenging one. 3 plus 2 times the absolute value of x minus 7 is less than or equal to 15. Okay, so subtract 3 from both sides. 2 times the absolute value of x minus 7, less than or equal to 12. Divide both sides by 2. Absolute value of x minus 7 is less than or equal to 6. There we go. X minus 7, less than or equal to, less than or equal to, and we're going to put a negative 6 here and a positive 6. Add 7. And we get a 1 here, less than or equal to x, less than or equal to 13. If I graph it, 1 and 7 and 13, and it's between those two values. Okay, pretty simple. Okay, another example. 5 minus absolute value of 2x plus 8 is greater than negative 11. Okay, so you shouldn't be looking at this right now and saying, oh, it's a greater than problem, it's got to be an or problem. You can only make that statement after you've isolated that absolute value. So if you've divided and you've cleared out all your negatives, because if you notice this guy right here, there's a negative. Okay, that's actually going to do something. Obviously, you know it's going to change things around. So let's solve it. I'm going to subtract 5 from both sides. Negative absolute value of 2x plus 8 greater than negative 16. Divide both sides by negative 1. So you get absolute value of 2x plus 8 is less than 16. It's a less than problem, so again, it's a between problem. So it's going to be 2x plus 8 is less than, and then negative 16 and positive 16. And then you solve. So subtract 8 from all sides. So negative 24 less than 2x less than 8. Divide by 2. And we get negative 12 less than x less than 4. Draw a number line. We have negative 12, 0, and 4. Open dot, and we're done. Now some of you might be asking, well, what happens if you get a problem that looks like this? Less than a negative value, negative 11, or greater than a negative value. Well, that's a good question. We're actually not going to cover it now, so you won't see any problems like this. We'll cover this in Algebra 2. You need to leave something for Algebra 2. So you won't actually get any problems like this. You will get problems, as we talked about back in the day, where you had absolute value of x minus 3 equals negative 11. And you should know, if after you isolate that absolute value, you have a negative here, it's no solution. Okay, it's only for an equal to sign. That's the type of problem we're going to cover. All right, so we'll do one more example here. And 3 minus 2 absolute value of x minus 4 is greater than or equal to negative 11. So once again, you look at this and it's greater, but we don't know what it's going to be. It's either going to be an or problem or between problem. So we're going to solve, subtract 3, negative 2 absolute value of x minus 4 greater than or equal to negative 14. Divide by negative 2. Okay, then we have absolute value of x minus 4 is less than or equal to 7. So it's less than or equal to, so it's a between problem. Not an or problem that we thought maybe it could be up here, but it actually turns out to be a between problem. And so we set up x minus 4 is between negative 7 and 7. We add 4 to all sides. So we have negative 3 less than or equal to x less than or equal to 11. And we graph it. Negative 3, 0, and 11. Okay, here's the last problem. It's the toughest problem of them all because it has the most just more parts to it. It still is an or problem or between problem, but it's got a lot more problems, a lot more issues with switching around the inequality. So let's try a problem here. It's 2 minus absolute value of 3 minus x is less than or equal to negative 5. Okay, so again, we don't know what it's going to be yet. Is it going to be an or problem or a between problem? Well, let's isolate the absolute value. So subtract 2 from both sides. We get negative absolute value of 3 minus x is less than or equal to negative 7. Divide by negative 1. So absolute value of 3 minus x is now greater or equal to positive 7. So it's greater than or equal to, so we're going to set up 3 minus x, so this is an or problem. We already know that. 3 minus x is less than or equal to negative 7, or 3 minus x is greater than or equal to positive 7. So we solve each one of these. We get negative x is less than or equal to negative 10. Divide both sides by negative 1, and actually we switch around the inequality sign again. And same thing with this one. That's going to be 4. Divide by negative 1. X is less than or equal to negative 4. Okay, but that's no big deal. It worked out well for us because if I graph this, it's still going to be a scarecrow, as I said before. Here's your 10. Here's 0. And here's negative 4. And it's greater than or equal to 10 and less than or equal to negative 4. So we still have a graph that looks like an or, it looks like a scarecrow. Nothing has changed. All right, so if I would have a problem where I'd have 5 minus x is between negative 3 and 8. It's going to be the same idea. You're going to subtract 5 from both sides, or from all three sides. You get negative 8. Less than or equal to negative x, less than or equal to 3. And remember, when you divide by a negative, you will flip the inequality signs around. So it's going to be 8 greater than or equal to x greater than or equal to negative 3. And then when you rewrite this, remember the inequalities need to point to the left. So I'm running out of room here, but you're going to have negative 3 less than or equal to x less than or equal to 8. And then you would graph it at negative 3, 8, and it's between. So you're going to make your barbell like that, and that would be the answer. So just be careful when you divide. You know the rules. When you divide by a negative, you flip the inequality sign around. Okay, so that's it with between and or problems. Hope you learned something, and good luck. Bye, algebra fans.